Okay, so we are looking at the logic problem from the intro discussion. And what I am going to do is take the separate statements that are part of the and statements. So on each chest, there is an and statement. And I'm going to kind of break those apart. So first we have the sign on box B is true. I'm going to call that proposition P. So that statement is going to be P. So I have that down in my little table. Then we have the sign on box A is false. I'm going to take that statement and call it Q. And then both of the chests, the signs say the gold is in box A. So I'm going to call that statement R. And so I've summarized those right here. So P would be the sign on B is true, Q, the sign on A is false, and R, the gold is in A. Okay, so we have three separate statements, and so I have made a truth table with those three separate statements here, and I have made every possible combination. And then I've also made columns that represent the actual signs, so the and statements. So the sign on chest A would be P and R, because this statement is R. And the sign on chest B would be Q and R. And we know that an and statement is true if both pieces are true. So I filled in those columns by first looking at just P and R, and when both P and R were true, that made the sign on chest A true. And then for chest B, I only looked at the Q and R columns, and when both Q and R were true, that would make the sign on chest B true. Okay? But I'm really not going to use those for the moment. First, I'm actually going to look at just the individual columns for P, Q, and R, okay? And what we want to do is just kind of try some things and see what causes a contradiction. And if it causes a contradiction, we're going to throw out that row of the column, okay? So first, what I'm going to try is I'm going to assume P is true. Okay, so P says the sign on B is true, and right now I'm going to assume that is a true statement. Well, if the sign on box B is going to be true, then both pieces would have to be true. That would mean the sign on box A is false, but then that causes a contradiction. Because if I assume P is true, and the sign on B would then have to be true, it then makes P have to be false, so it takes itself in a circle. Okay, so what that means is that if P is true, it causes a contradiction, and I can throw out every row in the table where P is true. Okay, so I'm going to highlight to cross out each row where P, the very first column, is true. Those are no longer valid options because it causes a contradiction. So that didn't work. So what that means is P has to be false. Okay? So if P is false, that would mean the sign on B is false. Okay? Because if P is false, then the opposite has to be true. So the sign on B also has to be false. But if we think about an and statement, the way for an and statement to be false is if at least one part is false. They don't have to both be false, but at least one part would have to be false. Okay? So we have figured out P has to be false. We've eliminated rows of the table. So let's move on to Q. Okay? So now what I'm going to try second is I'm going to assume Q is true. And because I know that sign B has to be false, that would mean R would have to be the false part. Okay, because at least one part of sign B has to be false. Okay, and let's see if that causes a contradiction. So if Q is true, that reads the sign on A is false. Well, we know the sign on A is false because we've already concluded that P has to be false, which would make the entire sign on A false. So that seems to work okay. And then if the gold is in A, if that part is false, then that still makes the sign on B false, which we concluded had to be the case from our first process. So that seems to work. Okay, we don't want to just stop though and assume that that is our scenario. We need to check and see if there's other scenarios that could potentially be true as well. Okay, so now I'm going to consider assume Q is false. Okay, well, if we assume Q is false, that would make the entire sign on chest B false, and that would mean R could be true or false. Okay, because we only need at least one part of the sign on B to be false. So if Q's the false part, it doesn't matter if the R portion is true or false. And let's see if this walks us into a contradiction. So what does it mean for Q to be false? So Q reads the sign on A is false. But if that statement I just said is a lie, then that would mean the sign on A is true. But we've already concluded it can't be because P is false. Okay, so we checked that, and this causes a contradiction. Okay, so what that tells us is Q has to be true. It cannot be false. So I need to eliminate any cases where Q is false. Okay. And then if we look at our table, it potentially looks like we have two scenarios. But remember, at first, in our first process, we need the sign on B to be false. And so if Q is true, in order for the entire sign on B to be false, then R would have to be the false part. It cannot be true, or the sign itself would be true, and we already know it's false. So we have found the only scenario that works. Okay? And that occurs if the statement, the gold is in A, is false. So that means the gold is in B. And that is our final answer.